Maybe we can get started. So yeah, Naomi, feel free to share your screen. So hello everyone, welcome to the IAU's Discourse series talk, being organized as part of by the working group, the executive committee working group of the junior members. And today it's our pleasure to have Professor Naomi McClure-Griffiths from ANU with us. So Professor Naomi McClure-Griffiths is a radio astronomer, a research professor at Australian National University, and also chief scientist of the SKAO Observatory. She completed her bachelor's degree in physics from Oberlin College and then earned a PhD in astrophysics from University of Minnesota. She then moved to Australia to join CSIRO's Australian Telescope National Facility and then moved to ANU. Very recently, she was appointed as the chief scientist of SKAO, where she is leading the observatory science strategy to maximize its overall scientific return. Her research, coming to her research explores how atomic hydrogen gas, magnetic fields, and feedback from stars shape the structure and evolution of the Milky Way and nearby galaxies. She led the discovery of previously unknown spiral arm of the Milky Way and has been and is still playing a leading role in large survey with the Australian SK Pathfinder to survey especially gas cap and possum. She has an ample experience in supervising and nurturing young talent with more than 50 PhD students, masters, students, and postdoctoral fellows. She has received numerous awards and honors, including Malcolm McIntosh Prize in 2006, the Posse Medal in 2015. She was elected to be Fellow of Australian Academy of Sciences in 2022, and very recently, the Astronomical Society of Australia's Ellery Lectureship for outstanding contributions to astronomy in 2025. With this introduction, I would ask Naomi to take it over, and she will talk to us about SKAO, the radio astronomy for the future. Please, Naomi, take it.
Thank you, Amit. Hopefully you can all hear me okay?
Yep.
Yep, great. Okay. Well, that was a very embarrassing introduction. It's always somewhat embarrassing to hear things about yourself, but hopefully I can tell you some fun things about the SK Observatory over the next little while. So as Amit said, I'm recently started as the SKAO chief scientist. And so what I want to do is tell you about what SKAO is going to be, how you're going to get data, and how you can get involved. And for some of you, looking at the names that I'm seeing on the list here, for some of you, you'll know a lot of this, and we can have questions and things at the end. And for some of you, maybe this will be somewhat new. Shout if you have questions or something's really unclear. I can't see people while I'm showing my screen, of course. So before I go any further, it's really important that we recognize and acknowledge the indigenous peoples and the cultures that have traditionally lived on the lands on which our facilities are located in both South Africa and in Western Australia. And in Australia, we acknowledge the Wadjuri Yamaji as the traditional owners of the land on which the telescope is being built there. The telescope site is called Inyari Mana Ilgari Bundara. It's the CSIRO Murchison Radio Astronomy Observatory, and that's the site where the SKAO telescope is being built. And I'm speaking to you from Ngunnawal land in Canberra at the moment. So the next decades is a really exciting time for astronomy, and hopefully you're excited to be alive right now because we've got a lot coming on board. We already have ALMA doing millimeter and submillimeter astronomy. We have LIGO detecting gravitational waves. We have IceCube detecting neutrinos. We have the CTAO, the Cherenkov telescope, aimed to detect gamma rays. The ELT is under construction, the extremely large telescope, and the optical infrared. And we now have under construction the SKA Observatory and the radio to fill in this very full electromagnetic and multi-messenger spectrum. So what is the SKAO? And apologies to those of you who know all of this already, but I'll just take us back through the beginning. So the SKAO is 2 telescopes and at 3 sites. The headquarters are in the UK. The telescopes are in South Africa, the SKA Mid Telescope in South Africa and the SKA Low Telescope in Western Australia. And they make up one whole observatory. It's a big project. The construction cost of this observatory is over 1 billion euros. And we are a few years into the construction of the telescopes now, with the very first bits of science verification expected the year after next. So things are starting to get real. It is being built by radio astronomers, but the idea is that SKAO is for all astronomers. So this is a really important premise of the observatory, that it's no longer going to be the old days with radio telescopes being obscure and difficult to operate, but we will be producing full data sets that people can use that are ready for science. So just to tell you a little bit more about the 2 different telescopes, the Low Telescope in Australia is constructed, as I said, on Wadju Yamaji country in remote Western Australia. It's 131,000 log periodic antennas that look like big Christmas trees. These Christmas trees, if you haven't seen them in person, are taller than I am. That's not that hard to be, but you know, they're about 6 feet tall. And they're really quite impressive, and it makes an amazing sort of forest of antennas. They're arranged in 512 stations, and each one of those stations has 256 antennas in it. And they're spread out over about 74 kilometers is the maximum spacing, but very centrally concentrated with a lot in the near circles. So the circle that you can see on the screen where you've got the red circle there is the core where most of the stations lie. At the moment on the ground, there are about 14,000 of these antennas. So we're making good progress in construction. And there's some other numbers to wow you there. I'm always wowed by the 670 kilometers of fiber that has to wire up all of these antennas across the desert in Western Australia. And then on the other side of the Indian Ocean, we have the mid-frequency telescope, which is operating from 350 megahertz to 15 gigahertz with 197 fully steerable dishes. That includes the current Meerkat dishes and the Meerkat Plus or the Meerkat extension dishes that will be incorporated into the array once the SK dishes are ready to go. The maximum distance between all the dishes there is 150 kilometers, so this allows us to get good angular resolution. And at the moment, we have a few SKA dishes that have been installed already. So we're making progress there. So before I carry on, this is a lovely slide with lots of information. And I want to give credit in this slide because it is not my slide. And it, as with most of the most attractive slides in this talk, they have been created by various early career researchers who are working at the observatory now. We have a very young, strong team of observatory scientists, commissioning scientists, operators and analysts who are coming on board, and they make the most beautiful slides. So this is one that was made by someone in the operations team. So just to sum up what the telescopes will have, the Low Telescope at its first step for AA star will have 307 stations, up to 16 subarrays, 144 antennas for SK mid. And they'll be operating over the bands that you can see in the middle there. These are the frequency bands that we'll be covering, from 50 to 350 megahertz on low, from 350 to 1.05 is band 1 on mid, and band 2 will overlap that, going up to 1.7 gigahertz. And then we have the band 5, which is split over 2 sub areas there. And we will continue to build up the array. We'll be building up a full set of capabilities over time. So SKAO is an intergovernmental organization. And for those of you who may have worked with or used telescopes from ESO, it's like ESO in many ways. So it has been put together as a treaty organization from the members that you can see on the left: Australia, Canada, China, Germany, India, Italy, Netherlands, Portugal, South Africa, Spain, Sweden, Switzerland, and the UK. France is in the process of joining, and South Korea is hoping to join very soon. It's moving along very quickly. And Japan, we have very strong conversations going on for Japan to join. We're also in conversation with Poland, Ireland, Thailand, and a few other potential member states. So scheduling a meeting of SKA staff is basically impossible because they come from all over the world. But most of the people are located in headquarters or in the low or the mid sites. So you're all astronomers. The question is, why are we building this enormous telescope? And I could give you a full hour and a half or 3 hour long talk just on the science, but I'm not going to do that. I'm just going to cherry pick a couple of highlights because that's another conversation, and I want to let you understand how we'll get at data. But why would we build SK? Well, one reason is to see the evolution of the universe. And if we pick up our usual sort of diagram of looking through the universe, SKA low is tuned perfectly to pick up the epoch of reionization. The idea is that we should be able to see the hydrogen gas as it reionizes with the first stars and galaxies, and then to be able to map that in its full 3D structure. That's a really hard experiment, but it will be a very exciting outcome if we can pull that off. SK mid is tuned very well to see many things, but among them is to see the modern galaxies and the gas that surrounds those modern galaxies in the universe from, sort of a redshift of 2-ish up to the current time. Another reason for building the SKA is a big part of the strong science case is to use pulsars to understand gravity better. So using the best clocks in order to understand gravity and probe its details is a very strong part of the science case. Something that's very close to my own heart and is therefore in these slide decks because it's important to me is to understand the importance of cosmic magnetism. So this is one of my research areas and is a great strength of radio astronomy that we can measure Faraday rotation and polarization of synchrotron emission in order to be able to trace magnetic fields back through the universe. And those are just 3 sort of randomly selected examples that come from a wide range of science cases that we hope will be conducted with the SKA. These are the SKAO science working groups, which were developed early in the history of SKA to help design the telescope, because this is not a telescope or a pair of telescopes that were designed just to do one experiment or another. It's meant to be an observatory, which means it can do many, many, many things. And so we have working groups in cosmology, cradle of life, where we hope to be able to study emission from radio stars to see planets around stars, to study the epoch of reionization, as I already mentioned. Extragalactic continuum surveys studying AGN, black hole feedback activity. Extragalactic spectral line will be looking at things like OH megamasers and other non-atomic hydrogen spectral lines. We have a gravitational waves working group, which is working very closely with the pulsars working group. And the gravitational waves and pulsars working group are working hand in hand to be able to both follow up gravitational wave events, and also to be able to study gravitational waves through the pulsar timing. We have a working group on high energy cosmic particles, which is looking to install a guest experiment at the LOW telescope in order to detect cosmic rays directly. Atomic hydrogen, H1 galaxy science, again, another big area that was part of the earliest part of the science case. Magnetism, as I said, our galaxy, studying star formation and the structure of our galaxy. Pulsars, not just in using them for gravitational wave detection, but also understanding the equation of state of pulsars, solar and heliospheric and ionospheric science to be able to study our sun and what's going on from its radio emission. Transience is a huge part of the science case, where we want to be able to, with our wide fields of view, detect many, many transients and then to follow them up across the spectrum that is available to SKA. And we also will be using the SKA telescopes as part of very long baseline interferometry networks. So as you can see, it's a really, really, really broad set of science, and that was used to design the telescope. Many of people who are engaged in SKA science, and maybe some of you, were involved in the meeting, the Görlitz, that we had in Görlitz, Germany in July. Was it actually July? Maybe it was June, actually, now that I've written that there. And this is a picture of a bunch of the attendees. There were 500 in-person attendees and 200 virtual participants at this meeting. And including, and what I found to be really exciting, was a whole next generation of astronomers who will be the users of SKA. People my age and older than me have designed this telescope, but we're at the place where we're going to make it happen and then step back. And the early career researchers, this will be the set of the observatory for you to use and for you to make the unbelievable discoveries that will be coming up in the future. So the Görlitz meeting was really a wonderful set of energy. You can see some of the excited people in that audience there. From that meeting, I pulled together a word cloud of all of the abstracts, and you can just see the range of different things that people are talking about. SK, of course, came out first. I was pleased to see that magnetic came out high, galaxies, pulsars, the universe, feedback, angular momentum, energy. There's a huge range of different things that featured in the set of abstracts. So SKA science is broad, and if you do just about any bit of astronomy, you can probably find some way to use SKA in your future. But it is not just about science. Governments don't give us money they don't give us €1 billion to build great observatories just to do astronomy. That's I wish that could happen, but it's actually much better that we build observatories that have an impact more broadly. And so looking locally, the impacts are wide. Some of them include the partnership with the Wadjuri Yamaji indigenous community in Low. There's partnerships with the indigenous communities around the Mid telescope, and employment and cultural improvement opportunities around Mid. So the picture in the middle of all the little kiddies there, that was a childcare center that was developed. We invested in improving that childcare center in the very remote and quite impoverished town of Carnarvon near the Mid telescope. In South Africa, there's been an ongoing program, first led through Meerkat, to develop skills and training opportunities for people from all the way from school-aged up through university bursaries and training and PhD fellowships. And we recently have some people who have finished their PhD who were funded all the way from high school on through, and they're now doing astronomy, but some of them are also going off and doing other things that are not astronomy, and that's really important. I put in here also the respect for the land. I was recently in Western Australia, where the work on trying to keep a very good, strong handle on not disturbing the land any more than we have to as we build this telescope is really important. We have environmental monitors who come through to make certain that if this little tiny skink is near where we would be moving a piece of machinery, we don't disturb the skink. So there's a lot of very careful things there. And at the mid telescope, the land around the mid telescope has been declared a national park for rehabilitation, and it's already starting to develop more wildlife there than it was when it was a farming area. Globally, we're looking at impact and trying to improve our sustainability measures. So sustainability is a core value in SKAO. We'll be using in the early days up to 33% of renewables for our power. It's not easy getting power and building power stations at these remote sites. All of the remote antennas for mid will be powered by during the day with solar arrays, and nighttime that will have to go onto diesel. And you can see a picture of one of the solar arrays in Western Australia. We're also have been a foundation member in the IAU Center for Protection of the Dark and Quiet Skies. And that's an important part of what we're doing to protect our ability to do radio astronomy, but all people's ability to be able to see and appreciate the sky. So how are we going to get there? Well, and actually, where have we been? You know, you're young people who are looking to your future, and you possibly don't want to know the long and difficult path that has come in getting to SKA. But it is kind of amazing to see, and it's worth thinking about that facilities like this don't just appear overnight. We don't create observatories in 3 or 4 years. They have a long gestation period, and this one has been so far a 35-year journey. And just to make it abundantly clear, I have not been doing astronomy for 35 years. So this predates me, but the very first big ideas started in 1990 before I had even finished high school. And during the 90s, the science case evolved. But really, things took off in the 2000s as the technology started being explored. Funding and was sought for pathfinder telescopes and precursor telescopes like Meerkat and ASCAP, MWA, HERA, a range of different telescopes that have been placed on the sites of these two telescopes that we're building, but also have been testing out some of the technology. And some of that technology, like Meerkat, is going directly into the mid telescope. In 2012, the SKA organization was formed, and it worked on fully designing the telescope until 2021. The observatory was born through the treaty organization. And things have been moving fast since then. Construction started in July 2021, the commencement of construction ceremonies in 2022. And here we are sort of 3 years through construction, and that's about 50% through. More than 873 million euros of money has been committed to that process. There are a lot of people involved in SKAO. We have as employees about 360 people. That includes engineers, it includes project managers, technicians, business enabling staff in finance, communication. We have astronomers, but not as many. Most of the people who are employed at the moment come from the technical backgrounds. The number of astronomers is growing all the time, though, as we employ operation scientists, we employ commissioning scientists who are working straight with the data of the telescope as it's being built now. In South Africa, about 300 of the contractors are locally employed, giving jobs in the remote areas. And in Australia, we have about 300 contractors, including about 45 Wiradjuri and other indigenous people out in Western Australia. And there are 1,600 or so science working group members who have been involved in designing science cases for SKA. There's a lot of high vis that happens and a lot of hard hats to make this come to life. So where are we now? So this is just trying to trace the buildup of the SKA. There are a number of stages in the delivery of the full telescope. The first stage is what's called AA 0.5, and that is actually finished for low. So that's the first 4 stations that were brought together. For mid, we're going to finish that stage hopefully by the end of this year. And then we'll track our way through. The first place that we will get data that will come out to the public will be in AA2, which I'll show you a timeline in just a few minutes. But when we get to AA star, so that's this array assembly star, that's when the telescopes will become operational and fully able to do science. And then we will slowly, we hope to expand it out to the full baseline of AA4 over the following years. Just to give you a sense of what happens between AA2, so this is an image, a simulated image of the Crab Nebula, what kind of imaging quality we expect to see with AA2 with the mid telescope, and this is what we expect to see with AA star. So over about a 2-year period, we'll sharpen up the resolution enormously so that it becomes a fully operational telescope. So the path from here, right now we're in this construction zone on the left-hand side. As I said, we have 14,000 antennas out in the desert in Western Australia now. It's probably 14,400 by now and going up at a rate of several hundred every day. It's really, really improving quickly. We are already in commissioning for the low telescope. And we have the first image that I'll show in just a second. Commissioning for the first bits of mid will come by the end of the year. And then starting in the first half of 2027 is when we'll move into a science verification stage. And there will be community involvement throughout that time until we reach operations in 2030. And what's going to happen with science verification is that we will observe a range of big standard sort of targets, choose your favorite radio galaxy, choose a good patch of the sky where you can test out the modes for EOR, observe these set of pulsars that we know, various different things. And then we will make that data publicly available so that you can download it, play with it. And we'll also ask for ideas from the community of what we should observe during those phases. Throughout that phase, the telescopes will be continuing to build up. So we will go through some science verification observations, do some more commissioning, do more science verification, more commissioning, and build up more and more beautiful and better quality data over about a 2-year period. So as I said, that'll start for low in 2027. That's really close. SKA, I said it's been going on for 35 years. We're coming close to it. For mid, it's a bit further away. We're looking at 2029, and I recognize that's beyond the horizon of postdoctoral fellowships, but not a lot beyond the horizon. So we are starting to move into that with operations in 2030 and 2032. So earlier this year, you may have seen the first SKAO image produced. This was produced with 4 low stations with the science commissioning team. That science commissioning team is led by 2 reasonably senior researchers, but it now has 4 people who are just out of their first and second postdocs who are really leading the charge and are getting to be the first ones on that data, which is really exciting for them. It doesn't look spectacular. It's dots, but the fact that it's real and it's a real image is what's so exciting for us, and it's only going to get better from here. Low has also been observing pulsars with the pulsar timing system, which is exactly the type of pulsar timing system that will be operational for SKA fully when it goes on. So this is a nice pulsar. In fact, there have been many pulsars. So these are several pulsars that are shown here. And there's now a set of pulsars that are observed regularly so that they can establish some timing of those pulsars and see how the telescope is performing. And then just as I started in my job as chief scientist, we had the first signal from the SKA mid telescopes, and then following from that, the first detection of H1, which was really exciting for me, and I got to be able to see that, hot off the press. And I can't tell you how wonderful it is to see something that you've been looking for from a telescope for many, many years to finally come to life. So how's it all going to work? Again, as I said, beautiful slides produced by early career operations scientists. So this is a beautiful slide. So the operational model is relatively standard, as you might imagine. You make telescope proposals, will request data. The telescope will observe those fields, and then it will be processed by the science data processor, the SDP. It will go through some sets of quality assessment, and then those data products will be delivered to what's called the SRC net, the SKA Regional Center Network. And that's what you'll interact with. So you will interact with the pink bits of this on the side, where the data products will go to the archive that is distributed around the world for SRCnet, but also that you will be able to work with your data in place using compute resources that are at those network sites. So the SKA Regional Centers Network is a federated network that will take data from low and mid sites and send it around Europe, Canada, Southeast Asia, East Asia, a range of different countries that have all logged in together, and to you it will look totally seamless. You will log into your local network and be able to pull data from anywhere. The idea is that it will be able to receive and curate and make available 700 petabytes per year of SKA science products. I find that makes me twitch with a certain degree of fear at how much data we're expecting to come from the observatory. The plan is that SKA will have probably 50 to 70% of its time ultimately will be going to key science projects. These are, the truly transformational, really exciting science that will be then legacy value for the full community. The leadership team for those will be restricted to people from member countries. So co-Is can come from non-member countries, but access to SKA is proportional to member share. And so leadership of KSPs will have to be from member countries. So if you live in a country that is not a member, try to encourage them to become one or join SKA. We also will have, and in the early years, most of the telescope time will go to PI projects, so standard projects like you're used to dealing with at most observatories, typically a bit smaller and without that kind of extremely transformational aspect. And all of that data will go on to the SRC net. So I want to spend a little bit of time about community involvement and how you can get involved, how you can stay up to date with what's going on. And I don't have all of the answers, but hopefully I have a few. So going back to our timeline here, the question that is, of course, on everybody's mind is, when will you get data? That's the key element. So the first bits of data, as I said, will come during science verification, and that's when the community will get involved. And we need people to be involved at that stage. Up until then, we will have had our internal commissioning team. We will have had some technical teams made up of experts from around the world who will help try to make certain that the observatory is working. But that's still only going to be dozens of eyes or 100 eyes on the data. When we get to IAU and we release what we think is good data, we then need the thousands of eyes out there in the world to look at that data, to compare it with things that you've done before, and to tell us, you know, yes, it looks great in this way, but it looks like maybe you haven't done the right thing on that, to kind of give a bit of feedback there. So that's verifying that it's science quality data. But it's also intended at that point to build trust in our community, within our community, of what we have done in producing the data. So that in the past, you may have, if you've used a radio telescope, gotten a measurement set and calibrated that and imaged it yourself, or at least seen the early stages of how that imaging was going. But we're going to give you already imaged data or already processed pulsar timing solutions. And we need you to trust that we've done the right thing in producing that. So the science verification stage is about giving you both the raw data and the data products so that you can go back and redo it, change it around, see whether you actually believe that what the observatory has done is right for the types of science that we need to be able to do. So you can look out for that. And we hope that by the end of that period, we're going to be producing some spectacular data sets, which will be of science quality to start using to do, you know, writing papers and doing interesting things. And we'll need your ideas to put those data sets out there. And then when we get to operations, that's, you know, that's lightning bolt time. That's the time when you can submit proposals, you can join, you can be parts of key science projects that will be going on during operations, and participating in full science data, like any observatory that you may have interacted with. So for early science verification at IAU, 2027 for low, 2029 for mid, it will be a very limited telescope at that point. We will have, for low, we'll have our long baselines, but not our core. We'll be focusing on continuum observations as our first bits, with lower priority to achieve pulsar timing and zoom modes, transient searches and transient buffers. That's just the very early stages, but as modes are commissioned, then they'll be offered for people to verify that. So as the year rolls on and into the next year, you can look to see some of the other modes come available for science verification. And for mid, the highest priorities will be both continuum observations and at least one beam for pulsar timing. It's really important for us that we get pulsar timing working well at the mid site, because we'll be incorporating the Meerkat telescope, which has been providing timing solutions for gravitational wave background searching. And we need to be able to continue that going forward in a fully contiguous way. And then other modes will, again, like with low, come up and be tested and offered for science verification. So science verification, the idea is that we'll be supporting the community with workshops and training resources, call for ideas. Those ideas can be submitted along with the ideas that we will have developed within the observatory. And we'll assess those ideas, and if they meet the needs of verifying modes, then we'll hopefully be able to take that data and make it public to anybody, is our hope there, not just member countries. And it should be public via the SRC net, which will itself be under development and building up at that time. So how can scientists engage with SKAO? There are a number of ways. One that I want to advertise right away is the SKAO will be starting a set of community webinars, the first one coming up on 18th of November. These are going to be every 4 months, and there'll be a way for you to get an update on what's happening with SKAO. We're going to talk about how we're going with construction, what's happening with commissioning, and then open up for Q&A so that we can get questions and give you feedback, or receive your feedback and give answers to those questions. Science meetings like what was happening in Görlitz is another great way. Participate in those meetings, hear the present your fantastic science ideas. Science working groups have been a mainstay of the way that SKA interacted with the community. That's evolving now, but they are community-led, forward-thinking groups about how best to do science with the SKA that have led to the design of the telescope and will help provide feedback as we develop modes into the future. There are jobs. SKA, as I said, has about 350 staff right now, but it's growing. You can always look at the career opportunities portion of the website for jobs. We should be advertising, I think, a couple more commissioning scientists, both in mid and in low, coming up soon. And there are various operations scientist roles that come in at times. There's a Q&A section of the website, so if you want to submit questions, get some answers, I don't understand how this mode is going to work, ask us. Somebody will get back to you with some answers. We are also building up to develop out some forums, so there will be user forums, which will be on the website. Under development, also KSP planning workshops, and a program of SKAO national ambassadors that I want to start up, which will hopefully be like the OLMA ambassadors program, if you are familiar with that, where people in member countries, we give a small amount of funding for an early career researcher to run workshops and training and to help bring the community together around SKA science in those member countries. So I'm hoping I'll be starting those up next year. In addition to international conferences and plenary talks, webinars, we're trying to get to all of the regional annual meetings. So if you're in Canada, that's the Canadian Astronomical Society. If you're in Australia, it's the Astronomical Society of Australia. In Europe, the European Astronomical Society. We'll try to have sessions at those to run networking sessions and town halls and try to build up the engagement there. And as we get closer to science verification, we'll be running science workshops and SK road shows of various different sorts. There are also things that are not just run by the SKA, which is really important to get involved in if you want to engage in SKA too. Various of the different science communities run conferences which are looking to SKA science, but are focused, they're built up by the community. So the FISC, for example, the Pathfinders and H1 SKA conference. Sparks is coming up soon, which is the SKA Pathfinders for Continuum Surveys. There are transient meetings that get together, not the meetings aren't transients, the meetings about transients that are looking to how they're going to use SK and how they have used Pathfinders. Most science areas have meetings and workshops, which are a great way to get involved in thinking about SK. How can you directly get involved? My biggest tip would be to develop your science ideas. Now is the time to start planning the big projects that you think will lead you out in the future, and then taking the data with Pathfinders now that will place you in good stead to answering those questions, the next big realm of questions. You can join a science working group and participate there. There will be soon plans coming out for how people can start to form key science projects as groups, and getting involved in one of those would be a really good thing to do. Look out for SK jobs. As I said, jobs come up, not just within the observatory itself, but also the SKAO regional center networks have been advertising a lot of jobs looking for data scientists and people to develop tools within those. So if you're really good with data, those are great. You can, in the future, volunteer for current future community testing opportunities. So as we start to test out some data modes, we'll be asking for some volunteers. And if you've got experience in working with other telescopes, that's a great opportunity there. And then when it comes around to science verification, we want you to grab the data and play with them. That'll be really important. So the QR code that I put up on the right is a link to sign up for our webinar, which will come up in November. I encourage you to sign up for that too, and come in here. We're operating it at 2 different time zones so that hopefully it's not in the middle of the night for anybody. And we'd really like to see you there. And I think that is all I've got. I'd love to take questions. I'll stop sharing my screen, I guess, so that I can take questions.
Thanks a lot, Naomi. That was a fantastic talk and very useful description and summary and involvement of SKA in various aspects. It's time for questions now. People, please feel free to raise your hand or directly ask questions. Either way is fine. While people are thinking their questions, maybe I'll take the opportunity. So Naomi, if, from this description, like what is your, throughout the whole building up of SK, what is your like most favorite and least favorite aspect of it?
My most favorite and least favorite aspect. I think my most favorite aspect is just seeing the new images, the new bits of data at every stage. So, you know, when we saw the first image come from low, it was like it's like if you're building a house and you finally get into the foundations and you get a sense of how big that room's going to be and you can see what it's like. It's really exciting at that point. So that is wonderful because it's going to just keep going like that. You know, radio telescopes are wonderful because you can create an image with 4 stations. But as we work up to 512, those images are going to get better and better and better. And likewise, you know, with a few dishes, we can make an image, but it's going to get better all the way along. So that's my favorite part. My least favorite part is probably the challenges that go on with when you construct a big telescope. It's really expensive, right? It takes a lot of money to do that. And you're constantly having to be checking against budgets and can you deliver the science? So my job as the chief scientist is to be the prime customer. So when the engineers are saying, well, it's going to cost more to make this little bit of the system. Do we really need that for science? I have to say, yes, you really do need that for science. Make it work. And there's always that tension, which is very healthy, but it's also it's a difficult part of the job.
Thank you. Thanks, Naomi. The next question is by Beth. Beth, please.
Hello, Naomi. Thank you for the talk. It was very interesting. I've got a question. Maybe it's more of a philosophical question. I've heard a few talks from SKAO about starting to discuss science projects and things that can be done with the SKA. But I guess where's the balance between like protecting your ideas so I can put in the proposal for it versus discussing it in the general community?
Yeah, it's a very valid question. So, you know, the science ideas where we want things for science verification, that data is going to be public data. And you're not going to be asking for like the really cool thing that you may have discovered some new thing in science verification. That's not what that stage is about. The place where, you know, you want to be discussing science is where you're working in a big collaboration, developing some big key science project that you might want to be part of. And you're going to need to work together. You know, for smaller PI type projects, we're not expecting you to be sharing those ideas. I mean, those are your ideas. It's your intellectual property, and we look forward to seeing them when they come as proposals to the telescope. But the big things are the things that help make certain that we get the modes right and the delivery right, and those we really need the community to talk with us about.
Okay, yep, that makes a lot of sense. Thank you.
Thanks. Giovanni, next, please.
Hi, Naomi. Thank you very much for the wonderful review. I really enjoy it. I'm Giovanni from the Observatory of Arcetri. So following your presentation, I've noticed actually that there is a dramatic gap in frequency between 20 and 40 gigahertz between the SKAO mid-band 5 and band 1 of ALMA, which a potential additional SKAO mid-band 6 receiver may fill. And in fact, many chapters of the science book, which is currently being prepared, emphasize the need that, an additional receiver, which could play a crucial role not only in our galaxy, but also in the study of external galaxies. So I was therefore wondering if now that the SKAO science verification phase is so close, so we are speaking about 5-6 years for the mid, the SKAO staff has resumed the discussion about the potential development of this new receiver. And I think you are the right person to ask.
I am the right person to ask. You're right. Yep. So on my to-do list, which is a pretty long to-do list, but on my to-do list is to start looking at prioritization for the next stages of SK. So science prioritization for that. Now, along with science prioritization comes the requirement to get funding to build those aspects. But one of the reasons why we have asked for the community to put the time into writing these chapters from the SK science book is so that I can take them, I meaning me and the whole observatory and the community together, and try to put that together into some kind of prioritization for, should we do band 6 first, or should we do more antennas first, or should we focus on getting a higher sensitivity receiver, or what kind of ways that we would want to be doing things. But it's absolutely on my radar that there's this very ugly gap between SK and ALMA. We can only go up to 25 gigahertz easily, but even still, that's a long way from 15 gigahertz up to 25. And that for things like cradle of life, our galaxy, star formation tracers, we get the frequency coverage, gives us spectral lines, it gives us the angular resolution. It's definitely on my radar.
Thank you. Thank you very much.
Are there any other questions for Naomi?
I'll take your questions on anything. I'm not scary.
Maybe I'll take the opportunity. One more. The SK, as you also showed, that it was built over a long time, right? An effort which is not just limited to one countries or few countries, like a lot of international countries over a long time, put in a lot of effort, money, and people power to do this. But there are unrelated events, like all international adversities, like whether COVID or wars and stuff like that. How does that, how much does that affect, and how much does that play a role? Because this would really help ECRs, because I think ECRs also are in the same kind of mix. So your views on
that? So I guess the recent and obvious examples, as you said, COVID and wars, those have led to it costing more to build SK than we thought it would cost. And that means that we had to, the original plan was to build this AA4. This is the full 512 stations, the full 197 antennas. And there wasn't enough money to do all of that because it costs more than we think. So we had to scale back, and that happened, a few years ago, and there was a scaling back process. That changes what you can deliver in operations and in construction phase, and that is always painful and unfortunate for observatories, because as astronomers we want the best and we want the most and we want it now, and sometimes it takes longer to get there because of events, and sometimes it costs more to get there. The other thing is that that priorities shift. Countries are excited about science for a while, but then 10 years later, they're not as excited about science. And it's part of our job as astronomers inside our countries, whether you're an early career astronomer or an ancient astronomer, part of our job is to keep it on the radar, to keep science on the radar, to keep the excitement on the radar so that it doesn't drop off as priorities change in countries. But it's, things go up and down.
Thanks, Naomi. So next is Saurabh. Saurabh, please.
Thanks, Naomi. That was really wonderful slide. So I had actually two questions, if it's okay to ask both of them in part. So my first one is, like, you talked about ECS getting involved with the science verification, but say someone who is a PhD student or like really young, I'd say young ECR versus senior ECR. So like how can, say, a junior ECR be involved in those kind of things when they have like less amount of experience? Because SKA will be like cool science, everyone wants to get involved there, but I'm guessing not everyone can get involved. There will be like competition. So like how
science verification, everybody can get involved. You can download the data. We will make the data available for anybody to download. Anybody can grab it and do what they want with it. Now there will be competition if it gets to a place where it's scientifically publishable, but that's not the primary objective in the science verification stage. If it's to familiarize yourself with data and how it's going to work, you can do that as a PhD student. You can do it as an honors student or an undergraduate. And we hope maybe there'll be some amateurs who download the data and have fun with it. So you can definitely get involved at that stage. But it's also a good place to shadow people who are more senior in your group. So if they're working directly with verifying some modes and going back and forth with the observatory, just ask to be on the CC chain and follow those emails, follow those forums and those conversations, because that's how you're going to learn to trust the data yourself.
And the second thing is actually about data products and archival data, because archival data has been like an important part of astronomy. But with SKA, there still be like big chunk of data, and I don't know if all of will be saved. Yeah, sure, in verification phase we might have to, but later on, so is there like I know it's not now, but say 20-30 years from ahead, is there a plan of archiving some of the data, or just like observe, deleted?
So the data products will all be archived, and where we hope that the archival science will come from those data products. So whether that's images or it's timing solutions for pulsars or whatever it may be, we can't keep the raw data, the visibilities. It's just there isn't enough data storage in the universe for us to keep it at this stage. But the data products definitely will be available. And in fact, I didn't mention this, there will be, through the SRCnet process of accessing resources for doing computing on archival data, there will be proposals for archival computing resources. The resources will not be archival, but they will be computing resources to work with archival data that will be part of that proposal process. So if you're in country X, that's a member country, you can apply for access through computing resources through the SRCnet and work on archival data, which we hope, and we know, as you very well said, that's where most science actually comes from observatories, is from archival.
Thank you.
Thank you. So next is Laura. Laura, please take it.
Oh, hang on. There we go. You should be able to see me in a second. There we go. Hi, Naomi. Thanks for that. That was really great. I've been thinking a little bit about this because as a postdoc, right, in particular, we have 3-year typical contracts, right? And the SKA won't be starting up until after that. So it is quite hard to think about really getting heavily involved in something that starts after most of our contracts will end. And of course, it's a bit depressing, but a lot of ECRs won't still be in astronomy then. So how do you think we can strategically participate when we're thinking about maybe community involvement and wanting to help the SKA be good, but it's hard for us to kind of imagine planning for KSPs and putting a large amount of effort into those things.
Absolutely. And, I mean, well, Amit works in, at my department. He would know that I would say, don't get involved in it right now. I mean, what I mean is get involved in Pathfinders, get involved in science that's leading to SKA science, because that's what's going to position you well for being able to lead the SKA science yourself in the future. But it's also going to mean that you get your papers out, you do what you want to be doing right now. That's the exciting place. But we need people who know how those pathfinders and precursors work, because they are the people who will know how the SKA data products should work too, because we're modeling these things off of that. So that's where I would put most of my attention if I were an early career researcher. But I'll just also back up with a slight anecdote that so I finished my PhD a very long time ago in 2001. And when I was applying for my first postdocs, I found the email that I sent to somebody at CSIRO at that time saying, I was doing my PhD in the US, I would really love to come to Australia and get involved in SKA. So I was just a little wee kid at that time, a young researcher. But I didn't get involved in SKA right away. I built up my radio astronomy skills. I got involved in science, and I got involved in leading science projects, including Pathfinder projects that we're leading up to. And I wrote in 2015 one of the science chapters for the SKA science book. So I was helping to define what SKA would do at that time, but it still fit within my career structure of leading to SKA, even though I was achieving things at that time. So we're in a different place now. You can't do what I did, but it does give a sense of, forward thinking. I was thinking about it then, a long time ago, maybe unrealistically at that time. But I do think that the bits of engagement, just going to an SKA meeting early on, getting involved in tiny bits, staying on top of it, listening to the webinar so you know what's going on, and doing your Pathfinder, precursor, and excellent science is the thing that will set you up to be the leaders in the next 10 years.
Thanks. That's great practical advice. I appreciate it.
Thanks, Laura, for the question. And Naomi, thanks for a very nice answer. I think this is very useful for ECRs in general. I see we are like way past time, but the excitement was there, so I didn't want it to stop. But with this, we'll end. Again, we'll thanks Naomi a lot for sharing our thoughts and more about SKA with us. And thank you everyone for joining. Thanks a lot.
Thank
See
you.
Bye.
Bye-bye.